In this video, I'm going to find the longest increasing subsequence of an array of integers, and I'm going to be using some dynamic programming concepts that I've gone over in previous videos. So if you're having trouble understanding this, check out the playlist I'm going to add in the description. And so to get started, what I'm going to do is I'm going to define a subsequence. And a subsequence is just, you can think of an array and you can imagine deleting any number of elements. And so basically you keep the elements of the array, but you need to maintain the order, and you're allowed to delete any number of the elements. So for example, we could just skip the number 1 and maybe skip the number 8, and this would be a subsequence. We could just take the numbers 1 and 7, or we could also even just take the number, a single number like just 8 would be a subsequence. And this problem's asking for only the increasing subsequence. So for example, 1, 2, 8 is increasing, but if we were to add in the number 4, that would not be increasing anymore because 4 is less than 8. And so you should be able to see that if we were to go over all the possible subsequences, that we would be running in exponential time, because for each element we have to choose whether to take it or not, and then we have to make that same decision from that point on. And we're just going to have to keep doing this, and we're going to end up with a giant tree of possible decisions of whether we're including elements or not, and that's going to run in exponential time. So we need to find a better way to do this. So one approach we can use is we can just imagine that we have the solution to whatever this problem is, and let's say that the solution's A, B, C. We'll just use these as stand-ins for whatever the actual numbers are. And we're going to imagine that we're going to introduce another number onto the end of the array. Let's just use 5 for this example. So if this is the solution to the subproblem, we know that if C is less than the number 5, that we can just append the number 5 on, and then we're going to have the new longest increasing subsequence. But it's actually not so simple, because what happens if 5 is less than the number C, so we can't append it on? But what if it's greater than the letter B, so that we can have one of these, we can have another sequence that's 3 elements long? Then we have to start asking ourselves some difficult questions about how we want to compare these elements and what we actually want to save and return. And it gets kind of tricky. And the good news is we actually don't have to think about this type of thing, because there's a better way to do this. One issue that I think makes this problem difficult is the fact that the last element in whatever the answer is isn't necessarily the last element in the subproblem that we're asking. And so what we might have to do is then have some type of pointer to whatever the actual last element is, so that we can do the compare with the element that we're trying to extend the answer with. And that obviously can be kind of tricky. So one thing we can do that actually simplifies the problem is ask a more specific question, which is not just what the longest increasing subsequence is, but what is the longest increasing subsequence where we force the last element to be the last element of the array. And then what we can do is we can go through and do that for each subproblem, so that we're then asking what is the longest increasing subsequence where we have 8 as definitely the last element, and then do the same thing with this. And once we go through and we check them all, you'll notice that whatever the possible answer is, it's going to have at least one of these numbers as the last number in the longest increasing subsequence. So when we then iterate through, we'll be able to pull out what the actual answer is. So I came up with an example just to illustrate this. The numbers at the top, in this top line in white, are the actual input array elements, and then the colored numbers are the answers to the subproblem of which is the longest increasing subsequence with the element above it as the last element, and then the actual subsequences I just drew in the same color as the number. And so you can see that for this array, the longest increasing subsequence ends in the element 7, and it has a length of 4, and it's just 1, 3, 6, 7. And so if we were to add this number 8 onto the end of the array, and we wanted to see if that changed the answer is yes, because 8 is larger than 7. And in order to find that in code, we would have to loop through checking all these things and keep track of what the longest, of what the new longest number is. And so for this, it would just be 5, because it'd be 1 added onto the 7. So for the actual implementations, we basically just have to walk through that same process. So we can either start with a recursive solution, and then just all you have to do is check all the previous elements and see if you can extend the result of that answer. Or you can do a bottom-up solution where it's just similar logic, and both run in quadratic time, at least after you introduce the cache to the recursive solution. And I think it makes sense to just run through those implementations. So that's what I'm going to do in the next video.